That makes sense because protein is higher density. Alyssa, here's your staff. Hang on to that. Okay, so pull out that page that we just looked at, and let's go through the answers for some of it. We won't waste really all the steps. Plus, I want to talk a little tiny bit about your homework. So for that number 1, and so these questions are off of the test, by the way, so this is good practice for your future. So Gabby, let's start with you. Which one is the good cholesterol?
That's
Right, good. And then Courtney, which one has the most protein? And then Stephanie, which one has the lowest density? Yep, that's right. And then which one transports cholesterol to the cell, James?
LDL.
Good. And then Chris, which one transports lipids from the liver to the tissues? That's right. And then Yelson, which one transports dietary lipids? That's right, good. Okay, and then for these next ones, these pictures, like the first one is sort of a giveaway. It's a steroid hormone, it even says it. But the important thing, is it polar or is it non-polar?
non-polar.
Okay, good. And then you should be able to describe the steps, right? And so some of you in your homework, there was a question like, how does a steroid hormone work? And what I got a lot of was, it crosses the cell membrane and then it delivers a response. And that isn't enough detail. Do you know what I mean? Like, I need you to give me the steps. So if I ask you on an exam to explain it, you need to be able to tell me what happened. So yeah, they do cross the cell membrane, but then what happens? Some of you said they go into the nucleus. And that was it. Well, yes, they do that too, but then what happens? You know, you have to give me the details. So what happens after they get into the nucleus?
Well, it turns on or off the transcription, and then it affects protein.
Exactly. Okay, good. So make sure that you have the steps. Yeah, Zach.
What was 1 and 2 on your steps?
Well, step 1 is probably it crosses the cell membrane. You know, and sometimes it binds to a receptor. You know, like sometimes it binds to a receptor that carries it, and sometimes it doesn't. So, but really, like it crosses the cell membrane. Probably step 2, it moves into the nucleus. Do you know what I mean? So.
I was looking for like enzymes or.
Oh no! I mean, like that's it, and then you know it will either activate. Like this one is activating transcription and making the protein.
Okay.
All right. Good. Then let's look at the second side. So flip to the second side. What is that top picture a picture of? What is that a mechanism for? An inositol phosphate. So is this for a polar or a non-polar hormone? A polar hormone. So does that mean, is it going to cross the cell membrane? No. It doesn't cross the cell membrane. And the important thing is, well, it binds, right? And then there is an enzyme in there, that G protein. Well, first of all, the G protein gets activated. What's another hormone that involves a G protein besides the inositol phosphate? Epinephrine, which is the one underneath it. So it activates that G protein, and then that G protein activates that 5-phospholipase. And what does the phospholipase do? It's an enzyme breaks apart a phospholipid, and you get two products. So one is DAG. What did that DAG stand for? Diacylglyceride. It's like a triglyceride, but it's a diglyceride. Do you know what I mean? That's really what we're talking about. That means, what is it made of if it's a diglyceride? Not two glycerols, two fatty acids, and what's the other thing? And glycerol. That's right. And then that activates something. You know, that will do something in the cell. Maybe it will activate glycogen to get broken down into glucose. And then the other product is that IP3, which stands for the inositol phosphate. It's like a sugar phosphate molecule. And what does that do?
Calcium.
It releases calcium, and then that means something is going to happen inside the cell. Okay, and we're not specific, especially in this one, because it can be different hormones. So what about the bottom picture? What's the bottom picture of? Epinephrine. Okay, good. And so what are the steps? Well, first of all, is that polar or non-polar?
Polar.
Polar. So does it cross the cell membrane?
No.
It doesn't cross the cell membrane. Okay, so epinephrine binds to the receptor, then what happens? Good. And the G protein activates adenylyl cyclase, which makes cyclic AMP. And then what does that cyclic AMP do? Because in this picture it doesn't really show, I mean, maybe it shows it activates a protein kinase, but ultimately what is that going to activate? An enzyme. What enzyme? So there's a couple too. It could activate phosphorylase, which breaks glycogen down into glucose, or glucose 6-phosphate, depending on where it is. And what was the other thing it could activate? Well, that's true, but I'm thinking of the lipases. Do you remember we said that that cyclic AMP can activate lipases? So if this is like in a fat cell, it can cause your triglycerides to get broken down into glycerol and 3 fatty acids. Okay, so it can activate either one, actually. It kind of depends on what cell it's in. Okay, so then let's talk about your homework a tiny bit. I looked at your page 165, so if I mark something on there, then it means it's not right. A lot of you had trouble forming a wax on question 14, and I just want to talk about that for a second. What is a wax made of?
Fatty acid and alcohol.
Good, and so what's a fatty acid look like? Carboxylic acid, and it didn't tell you, like, stearic acid is the fatty acid, and you do have to look that up. Do you know what I mean? Like the number of carbons and so forth. And then the other part is the alcohol. So I won't count the carbons, but it should look like this. Here's my carboxylic acid, and then here's my alcohol. And then how do they hook together?
Take water out.
Yeah, so it's not hydrolysis. What's that reaction where you have two things, you hook them together and you get rid of water?
Condensation.
Condensation. Hydrolysis is where you split them apart. And then what you should have is this. What is this bond that connects them? An ester. So some of you are really creative with this bond and it was not right. You know what I mean? So like this should be an easy reaction.
For like knowing like leolinic and like all those different kinds of acids, are we gonna have to memorize the structures?
No, I mean I will tell you them. I mean in the homework I knew you could look them up, but if it was on a test I would be specific.
Okay.
Since you don't have to have those memorized.
Okay.
I mean you should know that linoleic and linolenic are essential fatty acids, like that's important and what it means to be an essential fatty acid, but you don't need to know their structure.
Okay.
Yeah. Okay, so then let's see. Let's talk about page 166 for a second. And so some of what we just chatted about on your little practice sheet are sort of the steps for page 166. So we won't necessarily go through all of them, but I just want to talk about a couple of them. So for number 17, is epinephrine polar or non-polar?
Polar.
Good, so will it cross the cell membrane?
No.
No, okay, and we just talked about the steps, so I'm going to assume you have that right. Let's talk about number 18. And it's talking all about diabetes. And so what hormone is involved when we're talking about that? Insulin. And is that one polar or non-polar?
Polar.
Polar. So can it cross the cell membrane?
No.
No, okay. So where is the hormone released? Meaning, like, where does insulin get made?
Pancreas.
In the pancreas, that's right. And how will it get transported to the cells? In the bloodstream. It's polar, right? So it's soluble. It doesn't have to be carried by anything. So it just flows right through the bloodstream. And the hormone doesn't cross the cell membrane. We already chatted about that. So what are the steps, though? Insulin comes in and binds to a receptor. Then what happens? Those GLUT4 proteins travel up to the surface of the cell. And what do the GLUT4 proteins do?
glucose in.
Yeah, they transport the glucose right into the cell. Amy, what was your question?
On B, I have it that it's made in the liver, but released.
No, it's not made in the liver, it's made by the pancreas. Okay, good. And then number 19 is the inositol phosphate, but we already chatted about that, so I'm gonna assume you have that right. Let's talk about number 20. So these hormones, especially epinephrine and insulin, you should already know those because you learn that even in the metabolism chapter. So cortisol and aldosterone, let's start with those. So the cortisol, is that a polar hormone or is it a steroid? It's a steroid. Good. And so there is a function for that. It activates like carbohydrate metabolism. So it activates gluconeogenesis and it activates glycogenolysis. Both of those. I don't necessarily care that you have that memorized, but what you should know is it's a steroid hormone. That's really important. And then that means, is it polar or non-polar? Non-polar. And that means, will it cross the cell membrane?
Yes.
Yes. So it will go right into the cell and do whatever it's going to do. Okay, epinephrine you should already know. So is that polar or non-polar?
Polar.
Polar. And what does epinephrine cause to happen in the body?
Glycogenolysis.
Glycogen to get broken down. What's a fancy G word for that?
Glycogenolysis.
Glycogenolysis. But it also affects fat metabolism, right? So it also causes your lipids to get broken down into glycerol and 3 fatty acids. We'll learn about that more today. Okay, what about insulin? Polar or non-polar?
Polar.
Polar. And what does insulin do? 2 things.
Glycogen.
Bring glucose into the cell, and then what else?
Stimulates glycogenesis.
Glycogenesis. That's right. So meaning that you start storing that glucose as glycogen. Good. And then aldosterone, is that one polar or non-polar?
Non-polar.
It's non-polar. It's a steroid hormone, and this one regulates your sodium and potassium levels. Okay, and I don't necessarily care you have that memorized, but you do need to know it's a steroid hormone. Okay, and I mean, also I assume that you know that testosterone, estrogen, like the sex hormones, are also steroid hormones. Like I'm going to assume that you know that. That might be something I ask on an exam. Okay, 21 is something we did not yet talk about, but I am assuming that you can look them up. That's not so hard. So what is one of the fat-soluble vitamins? Vitamin A, good. And what is vitamin A for? What is it important for?
Vision.
Vision. Yeah, vision. There is another one that's an antioxidant, but vitamin A is most important for vision. And where can you find it? Yeah. It's like have you ever heard about, like, had anyone tell you when you were little that you should eat carrots so that you can see better, you know? You actually can get, interestingly, an overdose of these fat-soluble vitamins. So, I mean, if you ate too many carrots, you actually start to turn orange. I'm not sure how many carrots you have to eat. That seems like a lot, but it really it can happen. Anyhow, okay, so that's vitamin A. What's another one?
Vitamin D.
Vitamin D as in door. That one your body can make, but also you hopefully get it in your diet. And that one is, like, a lot of foods are vitamin D fortified. So what are some things that you can find vitamin D in? Milk, good. Orange juice, okay. Eggs, okay, so you know where to find it. Okay, good. And what's the important thing about vitamin D?
You can
Yeah, it's for your bones, you know, so your bones can absorb calcium properly, so it keeps your bones nice and strong. Okay, then, so that was A, D, what's the other one? E as an elephant, and that one is important for an antioxidant. That's right, but it's also put in foods a lot as an antioxidant, so as a food preservative. And where can you find vitamin E?
Avocados, kiwis.
Nuts, oils, things like that. Okay, good. And then the last one is K for blood clotting. That's right. And where can you find that one? Green stuff. You know, like K for kale, but also spinach and things like that. Okay, let's talk about number 22. 4 things that cholesterol does for you aside from cause heart disease. You know what I mean? But I want you to think of it as a happy thing. Like, why should you have cholesterol in your body? There's important things. So what are some things?
Membrane structure.
Okay, it's important for cell membranes. Good. Yep. If extra cholesterol can get converted to bile. What else? Yep. It is a precursor to hormones, and it's also a precursor to another vitamin.
Vitamin D.
Vitamin D. So, like, cholesterol is important, right? You just don't want too much of it. Okay, and then number 23. What is the general structure of a lipoprotein? So when you hear the word lipoprotein, it really means it's made of 2 things. What are the 2 things lipids and protein. What kind of lipids?
Triglycerides.
Like if you thought of the structure of a lipoprotein,
Or,
it's really phospholipids, and it's just a ring, right? It's almost like a micelle, but not exactly, right? But in the outside of it, we'll have the polar heads that helps keep it nice and soluble. What else is going to be pointing to the outside of a lipoprotein? The protein. And what's going to be pointing to the inside of a lipoprotein? The non-polar tails, and so that's where all the lipids are going to be stored, is in the core of the lipoprotein. So you need sort of two parts to it, right? A part that's going to keep the lipids soluble, and a part that's going to keep it soluble in water. Okay, and then the last page I looked at, and so if I marked anything on it, then you know to look at it. So question number 25 in particular, like I want you to be thinking about receptors. So I think a lot of you are thinking about diet. Like if I have a certain kind of diet, maybe if I just lived on Cheetos, I might have to worry about, you know, cholesterol. But I really mean like if you have a diet that's high in cholesterol, how does that affect the number of receptors that are produced? So be sure that you're thinking about that. And then number 26, the cholesterol is carried by lipoproteins, but how does it get brought into the cell? It binds to a receptor, then what? Endocytosis. And some of you are missing that piece. Okay, good. Then I think we're good. That brings us to our lab. So there's a couple of things. Pull your fat lab out for me. And turn to page 106. So look at part B, D. D as in door. So you guys have your lipids are, you know, the beakers that have the either the egg or the Cheeto. Those are back here in the hood. And all of that acetone is gone. So really all that's left is something at the bottom of your beaker, like the lipid that's left. So make sure you weigh this beaker first. That's really important. You're going to just test to see how much lipid you actually collected. Also, you want to kind of look at it and decide, does it look kind of solid in there, or does it look mostly liquidy? Do you know what I mean? So I can help you decide, like, is it more saturated? Is it more unsaturated? And then once you've weighed it, then you can do the cholesterol test. And so there's two setups in the hood, and you're adding acetic acid, sulfuric acid, and something else. I think phosphoric acid. Oh no, it's acetic acid. Acetic anhydride. Anyway, you'll add it just directly into the beaker, and you're looking for a color change. I think in the directions it says it will turn green, but sometimes it looks more brown. Anyway, it sometimes needs to sit before something actually happens. Do you know what I mean? So you can kind of add it and then just let it sit for a little bit, and then while it's sitting, at the very end, you can check it. Do you know what I mean? And once you've looked at it, then go ahead and rinse it out. This lab, really, you should have done. All you need to do is finish those last little bits of calculations and make your observations. So I'm going to collect this lab from you in class. That gives you some time to finish out the calculations and add in your comments. But otherwise, I'll just collect it from you in lab. So then the other piece of this, I want to put that back. That's not mine. The other piece of this is the soap lab. So I'm going to give you a new partner, and you'll do the soap lab. So I don't really care how you do this. If you want to make soap first, and then find your fat lab partner and finish that fat lab thing, that's fine, or vice versa, I don't care. But the soap part is pretty straightforward. So I have it right here. All you need is 5 grams of fat in a beaker, and it doesn't matter what kind it is. So you have lots of choices today. There's oils, so there's like 6 different kinds of oils, and then there's also lard. And you don't actually want to fear the lard because it makes really, really good soap. So I encourage someone at least to make some lard soap. So 5 grams of it. That means tear your beaker, and if you're using the oil, you'll drip it in there. If you're using the lard, you'll squirt it in there or use the spatula. And about 5 grams. If you get a little more or a little less, it's totally fine. Okay? So you'll drop that in. It's not very much, by the way, 5 grams. And then you'll also need a spinner, okay, a little plastic, it's a little magnet. And if you've ever noticed on the hot plates, there's a hot setting and then there's a spinner setting. And so this is to stir it. So when I say stir, I don't mean that you're literally stirring it. You're not doing that. You're using the spinner for it. So you'll get your oil or your lard, whatever you're gonna use, and then 15 mils of the sodium hydroxide. So listen, this is really strong sodium hydroxide. The 15 mils, about 15 mils, so measure it out in your graduated cylinder. But I want you to have gloves on when you do that, and then make sure you wash your hands afterwards, okay? And I prefer that you kind of pour over the sink. That way if you spill it, it goes in there and nowhere else, okay? And then once you have the fat and the sodium hydroxide and your spinner on a hot plate, and this part's really important, the first thing I want you to do before you put the beaker on the hot plate, make sure all of the knobs are turned off. That's really important. And then you're just going to click on the heat. So I don't even want it, I want it on the lowest possible setting. So just where you hear that very first click. And the same thing for the spinner. So you want it on really low spin. And sometimes if you have it going too fast, it will like splatter, and we don't want that because that sodium hydroxide, we don't want that to splatter. So you want a just real low spin, very low heat. If you have solid fat, it may have a hard time spinning at the beginning because it has to heat and melt a little bit. Do you know what I mean? But eventually you'll get it going, and I'll kind of come around and make sure that we're squared away on that. So really low heat and really low spin for 5 minutes. Okay, and then literally just take it off, let it cool enough so that you don't burn a hole through your locker, and then just leave it in your locker. Okay, when we come back next week, miraculously, it will be soap. Okay, and that's it. Leave the spinner in there. That's fine. We'll get it out later. It may not look like anything yet. So like today, when you do it, it's not going to look like anything, but when you come back, it'll look literally like a little bar of soap in there. So anyway, that's it. Yeah.
You just drop the spinner in the solution.
Yep, drop the spinner in, and then you'll pop it on your hot plate. Low heat, low spin, 5 minutes. Does that make sense? And then when we come back next week, we'll do the test on the soap. So we'll do things like foam tests and like how does it work with oil and stuff like that. All right? That also means there's no pre-lab and there's no like lab due for next time, which is kind of crazy. But that's good because your annotated bibliography is due, right? That gives you time to work on that. So annotated bibliography is due, a couple of pages. We'll have one last quiz next week before your test. And I think the other thing is your summary. I'm reminding you about that, but we're going to chat about that. Okay, anything else? Okay, let me give you a partner, and then you guys can get started. So I don't care how you do it, the order in which you do things, whatever you want. And when you're done, please wash your hands. That's really important. Please wash your hands, because even the stuff for the cholesterol test are really strong acids. So wash your hands, and then the rest of today, you have to work on your annotated bibliographies, but come to class, because we will talk about important things like lipid metabolism. Okay, so make sure you tell me if I've already given you this partner, but Kat and Alyssa, you guys are right next to each other, okay? And then Katria and Gabby. Okay. Then Jay and Zach. And then Chris and Hannah. Okay. Then Amy with an L and Stephanie. Stephanie could probably also this. Then Dylan and Courtney. Then Amy with an F and Sarah. Sarah's right next to you. Then Amy with a P and Leah. Guys are next to you.
Together on the last lab.
No problem. How about Amy and Rosie? Okay. And then Leah and Larissa. Okay. Okay. And then Yelson and Jackie. Okay. And then 1, 2, 3. So Anastasia, Cheyenne, and James. Okay. All right. So go ahead and get started. Goggles and lab coats. Gloves.
First and then do the
Would be good. You're ready to go, Larissa? Like.
Doing soap first. Okay. Okay, we'll do soap first because she has my lip back. Okay, good. Right, right. Yeah, okay, perfect. Oh, yeah.
Okay. So that's the first.
Do you work?
Wanna use lard?
Can you go straight from the gym
So
though?
we can get some nice soap.
I just have to go home and like.